Yo, what up, Sci fam? Let's get back into it and let's learn about the difference between a physical and a chemical change. Changes. Physical or chemical? You be the judge. So we need a page to define the difference between a physical change and a chemical change. And then we're going to use another page in order to list the 4 primary indicators that a chemical reaction has occurred. So let's start with a physical change. A physical change means that the atoms that make up the original substance are unchanged. So they remain unchanged. So this includes things like a phase change. So if I have an ice cube and it melts, it's still H2O. Even though it started as H2O, it's still H2O. And then if I add some more heat and that then turns into steam, it's still H2O. So we have H2O, H2O, H2O. It just goes from a solid to a liquid to a gas. So that would be called a phase change, as you guys know. So that is a physical change because it's the physical state going from a solid liquid to a gas that changes. If you have, let's say, a square of cardboard, and you take some paint and you paint it pink, and you end up with a square of cardboard that is now painted pink, that is not a chemical change. That's a physical change because you are changing a physical property. You are changing the color of it by adding something onto it. And the last type of physical change is maybe you have some awesome piece of paper and you're like, yeah, I can make this paper turn into a dove. Now, if you'd make that paper turn into a dove by folding it through origami, that is a physical change because you're just changing the way that the paper looks. So these are all examples of physical changes because you start with something and you end with the exact same thing. It's just in a new orientation or a different phase or a new rearranged shape or color. But it's not through chemical processes. It's just by adding something or rearranging the arrangement of the paper or whatever it might be. So phase changes, painting and folding, these are all physical changes. Like if you take a cup and if you slam it on the ground, it breaks into pieces. Yeah, it's new, it's different. It's a bunch of pieces on the ground now. It's an unfortunate event, but that's a physical change. So how is a chemical change different? Good question. The atoms that make up the original substances are now regrouped into different molecules. Okay, so I've kind of previewed this a little bit, but you can imagine that the atoms that make up the original substance are regrouped into different molecules. So if you start with A and B and C, when you end up, you're going to end up with A and B and C, but the way that they're going to be connected to each other is going to be different. So the new products have different properties compared to the original reactants. So I say the new products and the original reactants because whenever you look at a chemical equation, the left side of this arrow right here, we call these things the reactants because when they are mixed together, they react. And then after they react, they create a product. So you can think about like if you go to a store, you buy the products. Those are things that are made. And so whatever's on the right side of this arrow right here, yeah, those are called products. Okay, so let's look at this equation that I've got here. It could be confusing, but it's not too bad if we break it down. So we have vinegar and baking soda. A lot of people know that this is a chemical reaction. Well, let's see why, and let's prove that it is. So vinegar is the common name. The chemical name of vinegar is acetic acid. And you'll actually see it says acetic acid on a bottle of vinegar if you look closely. The chemical formula is, well, what atoms are connected together into a molecule to make acetic acid? The answer the chemical formula for vinegar is C2H4O2, which means there's 2 carbon, 4 hydrogen, and 2 oxygen. That's 1 molecule of vinegar. When we add that to baking soda, the chemical name of baking soda is sodium bicarbonate. The chemical formula for sodium bicarbonate is Na, which is sodium, and then HCO3. So there's a sodium, hydrogen, carbon, and 3 oxygens. That makes a sodium bicarbonate molecule. So when C2H4O2 is added to NaHCO3, we end up creating some new products. But again, remember that these products have to be made out of these same types of atoms. So let's see what it makes. We end up with some sodium acetate. Sodium acetate, the chemical formula is NaC2H3O2. We also end up with some water. The chemical name for water is dihydrogen monoxide, which the chemical formula is just H2O. There's 2 hydrogens and 1 oxygen. Di means 2, so there's 2 hydrogens, and mono means 1 oxygen. So 2 hydrogens, 1 oxygen means dihydrogen monoxide. And then also we end up with some carbon dioxide. The chemical name is the exact same as the common name. And the chemical formula is CO2 because it's 1 carbon and 2 oxygen. So if we back up now, if we look at our overall chemical, let's look at this here. Our overall chemical formula then, if we look at this, the products, the things on the right side of the arrow, are made out of the exact same things that we started with. It's just that these things all got rearranged into the new products, which is over here on the right side of our arrow. So you can see there's no new atoms that were created and no atoms that were destroyed in this process. You can see things like the sodium ends up here. The rest of it is all carbon, hydrogen, and oxygen. How that ends up grouping is sometimes in different molecules, and sometimes it attached to the actual sodium. All right, so this is one way you can tell that it's a chemical formula or a chemical reaction, is that if the products are rearranged into new stuff made from the original stuff, then it's a chemical reaction. If not, if it's like H2O solid into H2O liquid, there's no difference in the molecules, so therefore there's no chemical reaction. Most of the time, though, you can't actually see this chemical formula. You can't see that full thing. You don't see it. It's something that we learn after the fact, after we do some investigating. So let's look at the things that we can actually see, the indicators of a chemical reaction. You're going to want to start this on a new page. All right, so the first indicator of a chemical reaction is that there's a change of color during the reaction. And something you're going to notice with each of these is that this happens during the reaction. So when you add some things together, you end up with a change of color. So a good example of that is when you have a nail and it gets a little bit of moisture on it, plus oxygen, it actually causes rusting to occur. And that rusting changes the color of the nail, and it's now this brownish, yellowish color. So rusting is an example of a chemical reaction. Number 2, a precipitate. A precipitate forms during the reaction. Again, we see that. During the reaction, we get a precipitate. And a precipitate is just a fancy way of saying a solid substance. So for this one, as an example of a precipitate, is that actually the rust, I'm sure you've seen this before, but the rust is usually kind of flaky on the nail, and that's because the rust is a solid substance, and so we can call that a precipitate. So during the reaction of oxygen with the metal nail, we get the formation of a precipitate, which we call rust. So not only is there a color, but there's also that solid, flaky stuff. Number 3, a gas is produced during the reaction. So if we add an Alka-Seltzer tablet into some nice H2O, we end up with water that has a bunch of gas that's released because the water reacts with the Alka-Seltzer and causes the release of CO2, which bubbles up and pops and is released from the water. So a gas is produced during this reaction. And this is an example. Again, these are all examples of things that would let you know that a chemical reaction has occurred. The last thing is that a transfer of energy occurs during the reaction. And this energy is going to be in the form of either heat or light. And this is why, when people talk about chemistry, a lot of times they think of explosions. Well, that explosion is a transfer of energy that releases energy, and so energy kind of explodes outward from something that undergoes the chemical reaction. So sometimes, yes, there's an explosion, and there's a huge burst of light or even heat that is given off during the chemical reaction. So as an example of that, you can think of like a log that might be on fire. As it's burning, the burning process is turning that carbon in the wood into a new substance. It's rearranging the molecules, and in the process, it's releasing a whole lot of heat. So if one of these four happen, that means that there is a chemical reaction that is occurring, as long as these happen during the reaction. All right, so be a good observer. Make sure that you are paying attention and looking for indicators and things that would mean that a gas is produced, that energy is transferred, that a color change happens, or that a precipitate forms. All right, be on the lookout, and I'll see you later. Adios.